Hello, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm your host for today's session. And today we have a very thought-provoking topic that I personally am looking forward to with anticipation. And as we are in the habit of doing, before I introduce the Rozel team, or hand it off for the presentation, we'd like to run a couple poll questions just to get some feedback from the audience. No obligation or liability. It's strictly just to help our presenters understand your perspective. So if you would please, our first question is, how often do you or your clients review risk assessments? And again, there's no liability or obligation. We appreciate your attendance, and we strive to make the presentation as productive as possible, especially for your needs. Looks like we have about a 50% quorum, so let's leave this open another 10 seconds. All right. Again, thank you for your responses. Here's how folks have replied, which is encouraging. The second question is, do you feel your current risk assessment process is adequate? And again, this kind of dovetails into the situation that my regard, NFPA 70E is not a one and done situation. It's in flux virtually every quarter or every year. Certainly every 3 years when we update the standard. All right, we almost have a quorum. Let's leave this open another 10 seconds. Cool. All right, here's how people have weighed in. Looks like we're mostly in agreement with the topic that we're talking about. Thank you. The third question is, how often do you perform field safety audits with your employees? And this will be also reflected by your clients. This is a little trickier in my book. It's an interesting question. It's one that goes to the heart of, I think, we're talking about today. So we're about halfway to a quorum. Let's leave this open another 10 seconds. Thank you. Here's how people responded. Excellent. And then finally, does your company have a written electrical safety policy or program? And obviously this is where the rubber meets the road, so curious where things fall into place. We're about halfway there. Again, we send out by email an attendance certificate with the time attended by people that have joined the webinar, and that's usually 2 to 4 days after the webinar event. Looks like we're there on our quorum, and fairly good majority in people that I think are serious about the topic. So again, we appreciate your participation in the polls, and I'm looking forward to getting to the presentation. At this time, I'd like to hand the screen over to Brian Hall with Team Rozel. Brian, you have the baton.
Thank you so much, Jim. Hopefully everybody can hear me okay and see my screen. Let me put it in presenter. How do we look there, Jim? All good?
Yep, very good. Loud and clear.
All right, fantastic. Greetings, everybody. Thank you so much for attending our webinar today. And the title of our webinar is Have Risk Assessments and Job Briefs Gone Too Far? And so as Jim says, thought-provoking title to our webinar. Before we get going, let me just tell you a little bit about Rozel. So we are an electrical safety compliance company. We do just about anything and everything that revolves around electrical safety. And I would tell you there's generally two divisions to the company. On one side of the company is electrical engineering, and we perform arc flash studies. Slang term, right, for something known as an incident energy analysis. We perform incident energy analysis. We're a national company for in just about every state in America at this point. Company was established in 2010. On the other side of the company is electrical safety training, and so that is what I do. Travel the country, provide NFPA 70 electrical safety training for our clients. Again, thank you so much for having us here today and joining our webinar. Before we get going, I'll just briefly tell you a little bit about me. So I am the lead electrical instructor for Rozel, and I do have a certification from the National Fire Protection Association. So that is a certified electrical safety compliance professional. I've had that certification for a number of years. And I would tell you how I got started performing electrical safety training, and that is my background in the nuclear power industry. So I am from Cleveland, Ohio. That is where I am today. And here in Ohio, there are two nuclear power plants. There is one to the east of Cleveland, about 30 miles, and that is the Perry Nuclear Generating Station. And I worked there for many years. When I started at the Perry Nuclear Power Plant, my job was to be the electrical maintenance supervisor. So I had a crew of about 22 electricians, went out into the plant every day and performed electrical maintenance work on the equipment in the nuclear generating plant. And then I went on to be the electrical maintenance instructor. So in the nuclear power world, training is required. If you're working in that business, folks that work in that industry are required to receive a lot of training. And so it was my job to be the instructor or teach people to be electricians in the nuclear power plant. And certainly one of the things that I was required to teach was electrical safety. And so that's how I kind of got started providing electrical safety training. I am not an electrical engineer. I'm an electrician by trade. Ladies and gentlemen, I would tell you that I am very proud to say that. I am an electrician by trade. I really have never had a job where I did not work around electricity. My father owned an electrical contracting company when I was growing up. I'm 58 years old. From I'll call it my teenage years, I started wiring homes and bending conduit, pulling in wire, and doing all the things we do on the construction side of the trade. I did have an electrical contracting license myself in the state of Ohio for many years. I don't carry that credential anymore, frankly, just wasn't using it. Went into the industrial side of the trade about 1987, worked for the Alcoa Corporation here in Cleveland. We have a forge. Moved my way over to the automotive industry, worked for Chrysler. We had a stamping plant here in Twinsburg, Ohio. In a large part of my career at Alcoa and Chrysler, I was an electrician, went out every day with my voltmeter, amp meter, put my arc flash gear on, my rubber insulating gloves, performed the work, had moved my way into a management capacity. I was the facilities maintenance manager of the Chrysler Twinsburg stamping plant, right up until the point that it closed, unfortunately, and that's how I ended up in nuclear power. We're also joined by Adam Brooks and Jeff Kirshner from our engineering team today. They'll be online supporting me a little bit. We have questions that arise that relate to engineering. Jeff and Adam will be able to help me with those, but primarily I'll be the instructor today. So here's our learning objective. So basically, here's what we're gonna learn today. And so first of all, what we're gonna do is we're gonna compare and contrast the occupational safety and health records of high-risk industries such as nuclear power, where I used to work, to general industry types of employers. And we're going to compare the safety requirements of high-risk employers to those requirements of NFPA 70E. Now, again, the title of our our presentation today is "Have Risk Assessments and Job Briefs Gone Too Far?" And our answer to that question, or our short answer to that question, is no. Okay, they have not. And basically, we're going to make the case for saying this by presenting to you some proof of that. Okay, so what we're going to do is we'll look at the nuclear power industry. Okay, a very high risk industry, and what you're going to find is they have an extremely good occupational safety and health record. And what we're going to do is we're going to compare what the nuclear power industry does to the requirements of NFPA 70E and how those two things mirror one another. And and so the idea would be, how do we get more folks in the general industry to utilize these methods, or at least if you are using them, how do you make them more effective? All right, so currently there are about 93 commercial nuclear operators, or not nuclear power plants operating in the United States, about 55 locations in 28 different states across America. Generally, most of our nuclear power plants are in the eastern side of the country. We employ about 100,000 people in that industry, about 100,000 people currently working in the nuclear industry. That's according to the Nuclear Energy Institute. Nuclear Energy Institute would say about 500 to 800 workers are employed at each plant. That employment number can grow considerably when a nuclear power plant goes into a refuel. So at the nuclear power plant where I used to work in Perry, every 18 months, we had to refuel the reactor. And what we do in those situations is we shut the plant down, and hundreds of contract workers are brought on site to perform work. So the employment numbers can grow considerably during refuels. In some cases, the folks that come in to work during refuels are professional power plant refueling workers, if you will. There are a lot of very specialized tasks that need to be performed, removing fuel rods from replacing the fuel rods in the reactor, these sorts of things. And there are people that travel the country from nuclear plant to nuclear plant to do that, and very professional and work in nuclear plants all the time. And then on the other hand, we bring in many workers who have never performed work in a nuclear facility before. Utilize folks from union halls, electricians, welders, pipe fitters, laborers, scaffold builders. A lot of work is performed during refuel just because when the plant is running, radiation levels are so high, there are certain places in the plant you simply can't go. And so when the plant is shut down, a lot of work is performed. And consequently, again, a lot of workers are brought in. Let's think a little bit about nuclear power plants and the exposure to occupational hazards. Now, I think a lot of folks would think that most nuclear accidents in nuclear power are caused by radiation exposure, and frankly, that's not the case. Most accidents in nuclear power are very common to what most workers would endure or occur in a general industry type of setting. Okay, most common types of things: slips, trips, falls, things of this nature. Now, the interesting thing about nuclear power, at least my experience, is this, and that is that these plants were built to operate safely and not necessarily to perform work in. Okay, my experience prior to going to a nuclear power plant was working at Chrysler or Alcoa, and generally those facilities are all on one floor. The buildings are square. They have bays in which there are overhead cranes in each bay, which makes it easy to lift and rig motors off the top of equipment, move things around, a lot of open floor space, these sorts of things. When I got to the nuclear power industry, I discovered that is not the case. Nuclear power plants are built where there are multiple levels, and consequently, the equipment is densely populated, put together. There are a lot of equipment in small places. So nuclear power presents the greater risk, in my opinion, for occupational hazards or slips, trips, and falls, injuries due to these types of things. Plant design makes the work you have to work on scaffolds and climb ladders and these sorts of things. And again, the equipment is densely populated and presents multiple hazards such as trips. And so there's just a couple other examples there of what it looks like inside of nuclear power plants and what the typical workday would look like if you have to work on some of that equipment. Another, I'll call it risk, or what makes things more difficult or puts us at greater risk when we're working in nuclear power plants, is radioactive contamination. And so consequently, in some cases, we have to work like the worker you see there in the picture. We do have to dress in what we call anti-contamination equipment, suits. This equipment can be very hot when you go into your containment building. It's hot in there anyway, and then you put one of these suits on. It increases the risk for heat exhaustion and fatigue. You put your safety glasses on, your safety glasses fog up, your face is sweating, you get sweat on your safety glasses, but you got to be very careful about how you readjust your safety glasses onto your face, because if you touch your face with your hands, you can transmit contamination onto your bare skin there from your gloves. So it makes it very difficult to work in there. The gloves that we wear, in some cases, you have to put multiple layers of gloves on, because if you cut the gloves when you're handling screws, nuts, bolts, things like that, if you cut the gloves, again, you can contaminate your hands. And so you also have to be very aware of your intake of radiation, what we call dose. And so you're constantly monitoring through your dosimetry what your intake of radiation is. And so again, that could be another distraction, or just one more thing that you have to take to keep in mind when you're performing work inside a nuclear power plant. When I went to the nuclear power world, I would tell you that I was exposed to much more, I'll call it a higher risk of some electrical hazards. So when I worked at Chrysler, on occasion we might rack in a breaker or something along those lines. Arc flash hazards, much more exposure to those in nuclear power. It is a preventative maintenance driven industry. And so consequently, breakers, motor control center buckets, these things, this type of equipment is frequently racked off energized buses, racked off energized MCCs. The breakers are taken to the maintenance shop where routine maintenance is performed on those, and racked back onto that bus when it's energized. In some cases, incident energies could be very high, as much as 100 calories per centimeter squared. We also did a lot of grounding, motors and things like this. Again, we maintained, tested, and so the breakers that energized those motors were racked off the buses, and grounding equipment installed. And that could be hazardous as well if you don't install the grounding equipment properly. You could end up grounding your energized stabs inside of your switchgear, and so consequently a lot of exposure to arc flash hazards when you work in a nuclear power plant. The same thing would go for shock hazards. We do a lot of testing there that can be energized, Doble motor testing, things like this. Although the equipment is de-energized when we install the equipment, it is energized during the test. Working around much higher voltages. Again, when I worked at Chrysler, we didn't work on anything that was greater than 600 volts. In the nuclear power world, we work on anything between 135 volts DC all the way up to 22,000 volts AC, a lot of 4160, a lot of 13.8 at the Perry nuclear plant. And so consequently, we're at, I'll call it, more exposure to higher voltages than working in general industry in some cases. Now, nuclear power has a very good safety record, but they're not infallible. Okay, they have suffered some I'll call it some. They have had some issues with safety, and a recent one is in 2013 at the nuclear plant in Arkansas, Arkansas Nuclear 1. They were rigging and lifting a stator winding for their generator. Weighed about 1 million pounds, and they were going to remove that from the building. This is again during a refuel. Didn't do, I guess, a good enough calculation on how heavy this was. The crane that they brought in to perform this rigging and lifting activity failed, and that stator fell to a lower level. And unfortunately, some folks that were working on the lower level there didn't go home. Okay, so but again, here's another example of the type of work that's performed in nuclear power plants. We'll call it inherently dangerous, rigging and lifting large stator winding there. Now, if we looked at nuclear power in terms of their occupational safety and health record, this is some data that comes from the Bureau of Labor Statistics. We looked at nuclear power generation, and we could look at the total recordable injury cases, or total recordable injuries. And if you look across the top there, it says this is based on the number of incidents for 100 full-time workers working 2,000 hours in a year, right? So 40-hour week, 52 weeks in a year, we're working 2,000 hours. And so this is based on 100 workers working 2,000 hours. And so we looked at nuclear power and we just compared that to our fellow folks working over in fossil fuel, for instance, or other utilities. The incident energy, I'm sorry, the recordable injury cases are 5 times higher, much higher working in other utilities than it would be in nuclear power in terms of recordable injuries. And if you looked in construction, considerably higher. Okay, so I think the case we're trying to make here is that nuclear power, they do perform work that we would consider to be, in some cases, inherently dangerous. But they are able to perform this work very safely. Workers, the worker injury rates, recordable injury rates are very low in this industry. And so how are they able to do this? Well, let's break that down. And I think I would put it into just a couple of different things. And certainly one, workers are trained and they are qualified. And the way that this is performed, the training is what is through a systematic approach. They use a systematic approach. They do incorporate administrative controls. So a lot of work orders and procedures that are followed to perform the work. And then of course, pre-job planning is a big part of this. And so what we'll do is we'll just break these down one by one. I'm sorry, human performance is the fourth. So we'll break them down one by one. And so first of all, let's just talk a little bit about training. And if we were looking at NFPA 70E, certainly NFPA 70E talks about the use of the hierarchy of risk control. And training is one of the methods to reduce risk. And it falls under awareness. And so the idea is effective training. If we perform training properly, or it's effective, let me say it that way, when the training is over, our employees should be able to go back into our facilities, identify the hazards that they would be exposed to, such as arc flash as well as shock, and they would also understand what it is they can incorporate in terms of safe work practices to reduce that risk, right? So training does make people aware of how to identify the hazards and make them aware of what they can do to reduce that risk, such as wearing PPE and that sort of thing. So training can be an effective risk control method. Now, in NFPA 70E, as I explained, they use what is called a systematic approach to training. And it's really a 5-part process. And very familiar with that, a process, having been the electrical maintenance instructor at the nuclear plant there in Perry for a long time. And the way it really works is it is a cyclical process, if you will. And the first part of the cyclical process is analysis. And the idea is we really determine through just some sort of analysis what type of training is required for these folks to do this job. What training do they need? Okay, that could be technical, that could be safety, and frankly, it should be both. So our first step of our cyclical or systematic approach to training would be analysis. Identify the training needs. The next part would be design. Okay, identify what we would call our learning objectives. We really want to break down this training into parts. I call that the contract with my students. This is what you will learn at the end of my training, what we call our learning objectives. We would identify those in what's called the design phase. Then we'll talk about the setting. Okay, does this training need to be in a classroom? Does this training need to be out in the field on the job type, or do we need some sort of lab exercises so we have some hands-on aspect to this training as well? And so this would be the design phase. The development, this is when we actually sit down and develop our lab guides or our PowerPoint presentations, things along those lines. Then the implementation phase is you just simply go give the training. And then the third part of it, or I'm sorry, the last part, evaluation, is exactly what it says it is. Evaluate it. Did the training work? Did the training work? We actually try to determine whether or not the training was effective. Okay, and then that ultimately we end up back into the the analysis phase. Now, if we were to look at NFPA 70E, ladies and gentlemen, what I would tell you is that it doesn't say that we have to follow the ADDIE method or the systematic approach to training, but I think if you were to work your way through the requirements of 70E, what you would find is that it mirrors it very closely. First of all, you're going to find your training requirements are in Article 110.6, and 110.6 alpha is your training requirements for your qualified worker. And first of all, it says employees shall be trained in the safety-related work practices and procedures, procedural requirements as necessary to provide protection from the electrical hazards associated with the respective job assignments. And then it goes on to say the type of training, the type and the extent shall be determined by the risk to the employee. So NFPA 70E here is saying in the very first part of this that there is some analysis required, right? Not everyone is going to be exposed to the same level of hazard, right? So the training should hone in on that, right? What is necessary to provide protection from the electrical hazards associated with the respective job? Essentially, not one training is not a one-size-fit-all sort of a thing. So there is a bit of an analysis required in 110.6. Design. So NFPA 70E says the training required by 110.6 shall be classroom, on the job, or a combination of the two. Okay, so here again, this really kind of gets into the design phase of your systematic approach to training. Do we want these folks to sit in a classroom all day? Can some of this training be performed on the job, or can that on the job type of training supplement our classroom? And again, does this training require us to have some sort of hands-on type of thing? Generally speaking, we technical folks learn better by doing things, right? And so does this training, should we have some sort of hands-on type of aspect to this training? And so again, this is where we determine that in our design phase, and somewhat spelled out in NFPA 70E in that particular article. Development. So 110.6 alpha 1, it gives us some general things in terms of the development of the training, right? So it talks about the training should include things such as precautionary techniques used for working around the hazards, the proper use of PPE. It talks about using your applicable electrical policies and procedures. So you folks out there that said you have a written electrical safety program, all right, these things should be reinforced in your electrical safety training. You should be teaching the things that are required that are required in your electrical safety program. When I taught electrical safety in the nuclear power plant, we didn't hand out NFPA 70Es or OSHA 1910-269. We handed out the Perry nuclear power plant electrical safety program, and that's what we taught and built our electrical safety training around, right? It's your policies and procedures. So again, in this particular part of the requirements of 70E, it does talk a little bit about the development phase. Then we get into the implementation, and again, that is just providing the training, right? That could be somebody that's your in-house SME, or you bring in an outside vendor to perform the training. And the third part of it, and to me, one of the most important parts, is the evaluation phase. And NFPA 70E certainly requires this through the use of a field audit. Okay, field work shall be audited to verify that the principles and procedures of the electrical safety program are being followed. Goes on to say 110.6, and so again, that's part of the training side of things. The employer shall verify through regular supervision, or at least annually, that the employee is complying with the safety-related work practices required by the standard. Ladies and gentlemen, I would suggest to you that what NFPA 70E here is saying is go out in the field, watch your employees work. Are they able to take what they learned in the classroom and use that in the field? Okay, a field audit. This would be part of the evaluation phase, okay? Now, we're right back to our analysis, because what we're supposed to do when we perform our field audit, right, we collect this data. Hey, we're not using our gloves when we're inside of the restricted approach boundary. We're not performing the live, dead, live, phase-to-phase, phase-to-ground test properly, right? We identify where we have this gap in knowledge, right, by performing the field audit. Okay, we're not able to take what we learned in the classroom or in our training and use it in the field. We take that data and now we analyze it. Do we need additional training? right, or retraining. Ladies and gentlemen, it's a really good tool for your instructor if you have an SME in the field or in your facility performing that training. That data is vital. When I was the electrical maintenance instructor at the Perry Nuclear Power Plant, honestly, this was probably the primary way that I received my work. Folks would go out and audit and feed back to me, hey, Brian, we're not doing this very well, we're not doing that very well. And we would develop training to close that gap. Okay, so we're back to that analysis phase. Maybe what it tells us, hey, we're not performing a live dead live test very well. Maybe we need to spend more time on that particular learning objective during our training, right? Or figure out a different way to teach that, because for whatever the reason, that point is not getting across. So 70E again, 110.6 alpha 3 says additional training and retraining. Okay, employees shall receive additional training or retraining if the supervision or annual inspections indicate that the employee is not complying with the safety-related work practices. So I would suggest to you that is part of your evaluation phase that leads you back to your analysis. Retraining. Now, field audits. Interesting process, an annual field audit. And so we would suggest a couple of things to be successful when you go out to perform your field audits. And so first of all, we would suggest that you build some sort of a template that would be included in your written electrical safety program if you don't already have one. And maybe that would be just sort of a checklist that you check off as you watch people work. And again, you want to make sure that you capture this data. Okay, so you have something that you can take back to your team that determines whether or not you need additional training or retraining or where you need to concentrate those efforts. We would suggest that performing a field audit properly might take a little training in and of itself. Okay, to perform that audit properly, in some cases you might have to have a critical conversation with your employees, and these sorts of things reinforce your positive audit findings in your audit, and be able to have, again, critical conversation on the things that we need to. A little training can help there. And then auditors have to know what to look for, right? You can't perform an effective audit unless you understand the rules yourself, if you will, or you understand NFPA 70E. And so we would suggest that auditors receive NFPA 70E electrical safety training. Doesn't necessarily mean they have to be a subject matter expert, but when supervisors are out in the field watching their employees work, they would certainly need to be familiar with the safety-related work practices that their employees should be following. We do have a little template there that we have on our website. More than welcome to use that if you go to our resources page, and you can find a template that we often use for audits. All right, the next piece of nuclear power and how do they ensure safety of their employees as well as the public, what we call nuclear safety, is through the use of administrative controls. It is a very rule-based industry. Everything that you do in a nuclear power plant, ladies and gentlemen, generally you're following some sort of procedure, some sort of written rule on how to perform this work. Work order is also included in that. Work is planned, and there are documents that tell us how to perform the work, and again, procedures included in that. They get down to the step-by-step process of performing it. Procedure use and adherence is mandatory. Okay, it is mandatory. You have to follow your procedure when you're performing the work there. Okay. Procedures could look a couple of different ways. You can have what are called standard operating procedures, or what we call SOPs, and those are exactly what they say they are. Generally, this is how to operate equipment, turn things on, turn things off. In some cases, they have to be turned on and off in a certain order. Maybe you're exposing yourself to a considerable arc flash hazard when you're doing that, and so again, safety needs to be included in your your procedures. Then we can have also what is called a standardized work instruction, SWI. This is going to be very task-based, detailed, step-by-step, how to perform a task or job and do it safely. And a lot of the things that you see there should be included: description of the work, applicable drawings, lockout, tagout, requirements, all things along those lines could be and should be included in your standardized work instructions. Now, NFPA 70E, again, let's compare the two things. 70E Article 110.5 says the employer shall implement a documented overall electrical safety program that directs the activity appropriate to the risk associated with the hazards. So one of the reasons we asked earlier on, did you have a written electrical safety program? Really appreciate you guys responding to that poll. Looks like a lot of folks out there do. Again, required by 70E. Now, one of the things that we use when we provide written electrical safety programs for our clients is the document actually that NFPA 70E produces there on how to put together a written electrical safety program, or their guide to do that. And one of the things that you would find in that particular guide there, as well as there's some information in Annex E in 70E, would talk about the procedures that should be included in your written electrical safety program. And it's not limited to these things. These would be just examples. And so by my estimation, what you look at is things that are more high risk, right? Certainly racking breakers or installing protected grounds, switching mobile equipment near energized lines, all these sorts of things. This is where you would have a written or standardized work instruction in order to perform that work. If your employees follow the procedure as it's written, you certainly would reduce risk of arc flashes or shock or electrocution or exposure to other hazards as well. Now, I always give two examples of administrative controls in terms of procedures. And the first one is just a lockout tagout posting. And just try to give me an example, if you're not familiar, how these things can work and how powerful they can be. And first one is just a lockout tagout. The idea is with a lockout tagout posting, I could come to your facility, having never been there before, and lock out and tag out a piece of equipment, never having worked on it before, and do it effectively, because all I really have to do is look at that posting there, or that procedure that tells me exactly what it is that I'm supposed to do in terms of isolating the electricity or the gas or the water. And it's visual, there's pictures there. It's a step-by-step process that walks me right through that. Again, if I adhere to that posting or procedure and I do it exactly as it's written, considerably less risk of making a mistake or not missing something than if I were trying to do it just by memory or not having the procedure, trying to figure it out on my own. Now, we can do the same thing for electrical tasks. In the example there on the right, one of our clients has a nice procedure written for just opening up a pump disconnect switch, and in some cases, their equipment needs to be shut down in a certain order. There's high incident energy there, 12 calories per centimeter squared. And so this little posting here tells the employees exactly what it is they need to do to safely and effectively de-energize or re-energize the equipment. So again, a good example there of administrative control in terms of procedures and how they can be used effectively. Job briefs, okay, is another one. So another tool that we use in nuclear power to ensure health and safety of workers. And really, if you think about nuclear power, they are required to follow an OSHA standard 1910-269, okay? And that standard 1910-269 is specifically for electric utilities, if you will. It is entitled the Generation, Transmission, and Distribution of Electricity. And so OSHA 19-269, Charlie would say that before each job, the employer shall ensure that the employee in charge conducts a job brief. And subjects to be covered are included in that particular paragraph in OSHA 269. Talks about the associated hazards with the job, work procedures, special precautions. These are the things at a minimum should be discussed during your pre-job brief. The idea is to identify the hazards prior to going to perform the work and build a plan in order to mitigate that risk. Now, NFPA 70E, again, same thing. If we looked at the requirements in NFPA 70E, it's going to specifically talk about job safety planning and pre-job briefs. And frankly, if you looked at the words in NFPA 70E, they mirror OSHA 269 pretty closely. It says before starting each job that involves exposure to electrical hazards, the employee in charge shall complete a job brief, safety plan, and conduct a job briefing with the employees involved. And it goes on to talk about, again, what should be discussed in that job brief. And again, if you look at it, pretty much mirrors what's required by OSHA 1910-269, and that's generally the template, again, that the folks use over in the nuclear power industry. Now, job briefs, have sat through many, trust me. When I worked in nuclear power, when I was in the nuclear power industry, it was required that the supervisors sit through every job brief. And that requirement may not be the same in today's world as it was then, but we sat through every job brief at the Perry nuclear power plant that our employees were going to go out to work. And there are some things that we have to be careful about when we perform job briefs. And one would be lecturing rather than discussing, okay? The employee in charge, that is, doesn't necessarily have to be the supervisor. In fact, I just sat in the job brief. I did not facilitate the job brief. That would be the person that's kind of going out and leading the job. And so the employee in charge can look a lot of different ways. It could be the supervisor, but doesn't necessarily have to be. Job brief, generally, you're going to have some sort of card or checklist that you use to get through the job brief. And what I would suggest is that the employee in charge should go through that checklist prior to performing the job brief and only check off the things that are necessary. In other words, what are the things that we need to discuss in this job brief? Don't go through everything on the checklist, okay? It should be a job brief, right? It should be a job brief. When we start getting things that are very long and drawn out, people's attention tends to wander, and so we're not engaged in the brief. It should be to the point. And so long job briefs generally not a good idea. It depends on the scope of the work, obviously, but typically it should be a job brief. Everybody should be able to have stop work authority, and that should be discussed in the job brief. And then one of the things is that oftentimes it's just, okay, we have to do this. Let's just get this done, this job brief. And so we're not engaged. We're not thinking about the work. We just check the boxes and go to work. I will give you a couple examples, ladies and gentlemen, of job briefings and how important that they are. And I'll give you just a couple of examples I like to use from just OSHA accident reports and these sorts of things. And in this particular case, unfortunately, a worker lost their life, and what they were doing is trying to change a photo cell, like what you see in the upper right-hand corner of the picture there. And unfortunately, they were performing this work with the power on. And the photo cell just turns the wall-packed light, like you see in the lower left of the picture there, on or off. When the sun goes up, light goes out. When the sun goes down, the light turns off, right? Now, if you've never changed a photo cell before, ladies and gentlemen, what I would tell you is that that's a pretty easy job in terms of electrical work. Pretty simple job. Generally, you got to install a couple of wire nuts. And in this case, this fellow was standing on a ladder 22 feet off the ground. And he crawls up this ladder. Again, he's working with the power on, and he makes contact with one of the wires. He gets knocked off the ladder, falls to the ground, hits his head on the concrete parking lot. They take him to the hospital via helicopter, and unfortunately loses his life at 4:30 that afternoon. Now, another fatality, unfortunately, is the Eddie Adams story. If you're not familiar with this particular story, it's readily available on YouTube. And the idea with the Eddie Adams, or what happened to Eddie Adams, let me state it that way. Eddie Adams worked for a company down in North Carolina, and by all estimation or interviews of the folks that are involved in the little video, Eddie, really good electrician, had worked at this particular facility for a long time, very familiar with the equipment, and a good electrician, well trained. And Eddie takes his voltmeter that's rated for 1,000 volts, and he puts it across a motor starter that's energized at 2,300 volts. Now, this particular motor starter on the cover or on the front panel had a label on it that clearly stated that inside of this equipment the voltage was 2300 volts. 2300 volt equipment physically looks different than 480 volts, right? So there's a lot of things leading Eddie Adams to tell him that this is not 480 volt equipment. However, Eddie has this mental model that this particular equipment that he's going to work on is 480 volts. He even explains that to the ambulance driver on his way to the hospital, because when he applies the 1000 volt meter to that 2300 volts, it creates an arc flash. Eddie, unfortunately, is not wearing arc flash gear and succumbs to those burn injuries. Ladies and gentlemen, this is a story that we use in our electrical safety training, and it really is a case study in why it is that we need to perform pre-job planning. I would suggest to you in either one of these cases, had we discussed the hazards of working on a ladder 22 feet off the ground, not working with gloves on, if we're not going to shut off the power, in which we absolutely should be, right? Locking it out, tagging it out, verifying it, right? Maybe working in a man lift versus standing on a ladder. Same thing with Eddie Adams. Had he had a job brief prior to going into this MCC room, he would have understood that, hey, wait, oh, this is 2300 volts, right? It's not 480, right? Sit down, think about the work prior to performing the work, identifying the hazards. Should have had on arc flash gear, right? We need different equipment to work on 2300 volts. Job brief and pre-job planning, very important. Very effective tool for reducing the risk of injury or worse. So let's talk a little bit about human performance. Human performance, a really big piece of the puzzle in nuclear power in terms of health and safety of their workers. And the idea of human performance is very simple. Humans make mistakes. Humans make mistakes. And unfortunately, mistakes when we're working around electricity or other examples, high-risk industries, the outcomes of mistakes are unacceptable, right? Certainly Eddie Adams made a mistake, put a 1000 volt meter across 2300 volts, simply made a mistake. There can be tools and techniques used to reduce this risk, okay? And so this is what we call human performance. Now, if we looked in NFPA 70E, same thing. It would say that our risk assessment procedures, so your risk assessments are required by as part of your written electrical safety program. It says your risk assessment procedures shall address the potential for human error and negative consequences on people, processes, and the work environment. Okay, so this is really all it says in terms of the requirements of NFPA 70E in Article 110.5. It just briefly talks about making sure that we address the potential for human error. Now, if we were to dig a little bit deeper in NFPA 70E and we were to look in informative Annex Q, an extremely good annex, ladies and gentlemen, that talks about human performance and human error. And I'll just give you a few of the bullets here that mirror what's in NFPA 70E Annex Q there. First of all, it's based on a few principles. The one is that people are fallible, right? Even the best people make mistakes. However, what we call error-likely situations are predictable and preventable, and incidents can be avoided. And individual performance certainly is influenced by our organizational processes and values. So it really, at the core of human performance, I'll say it that way, is this concept. We talk about human error can be provoked. Let me say it that way. Human error can be provoked. And so in NFPA 70E Informative Annex Q on page 94, you'll see something that looks very much like this. And these are what are called error precursors, ladies and gentlemen. These are things that make us more likely to create an error. Okay, it's not saying that you will, it just puts us at an increased risk. Now, if you notice the first one there, it says time pressure under what is called task demands, right? So simple example. I mean, if you're late for work and you're rushing around the house trying to get out of the house quickly to get to work, are you more likely to forget your wallet or your purse or your lunch or your watch? Most certainly, right? If we're rushing, it does make us more likely to make a mistake. Now, oftentimes I think people assume the word time pressure means that the employee is under pressure from management to perform the work quickly. That can be the case. However, I would tell you that time pressure can be internally applied as well. Okay, and I can give you many examples, but one would be it's Friday, right? And our son is pitching in the Little League World Series game. And if I get out of work on time and get home and get a shower, I can get to the game and watch my son pitch. However, something breaks right at the end of the shift, and I'm the guy that has to get it fixed, and I can't leave until I do. And so consequently, I'm going to be rushing, right? I'm under time pressure. Nobody's telling me to get it going quickly, the machine going quickly. However, I've applied that pressure to myself internally. Okay, so time pressure can look a lot of different ways. And so there is a whole list here of what are called error precursors, right? Distractions, interruptions, personality conflicts. Over at the bottom, bottom of the column on the right side of the page, complacency, overconfidence. All of these things are what we call error precursors. In my electrical safety training, I always like to give this little example. And what I ask my students is, if we have to go to this pickup truck in the upper left of the screen there, what's the quickest way to get there? And obviously the answer to that is through the ice and the snow, right? That's the quickest way. And then the next question would be, is that the safest way? And the answer to that obviously is no. The safest way would be to go around the pole to the right where the ice and the snow has been cleared off. That would be the safest way. And so the idea of the slide here is the safest way is not always the quickest way. Right? When we find ourselves under time pressure and these sorts of things, it can lead us to take that shortcut versus taking the safe way around the pole. We know our safe work practices. We know we're supposed to put on our gloves. We know we're supposed to lock out and tag out. However, our error precursors come into play here, right? And so now in order to save a little bit of time, we don't go to the shop and get our gloves, right? Safest way isn't always the quickest way. If we follow our safety rules, it will take us a little bit more time in order to perform the work. Now, having said that, if we think about the shortcut, I call it there, the fast way to the pickup truck there, how much time do you really save by taking the shortcut? And the answer to that question is not really much, right? A few seconds. And when we think about following our safety rules, the things that are designed to keep us safe, at the end of the day, it really only takes us a few seconds to be safe, right? The time it takes to put on some rubber gloves, the time it takes to slip on some arc flash gear, time it takes to verify our meter properly before we use it to test for an absence of voltage, time it takes to sit down and perform a job brief, right? Safest way isn't always the quickest way. We follow our electrical safety rules. It might take us a few seconds of time. However, we're going to get to the pickup truck, right? And let's call that home. Right, wife, kids, husband, families, safely every day. Electricity can and will hurt us, and so this is just a way to reinforce. Again, taking a little bit of time, identifying time pressure, and making sure that we still follow our rules. It doesn't take a long time to perform the work safely. Okay, so if we follow that up with the other side of the coin, are what we call our human performance tools. Okay, so these are things that the nuclear power industry uses extensively, I'll call it that, are what are called human performance tools. These are things designed to reduce the risk of human error. And so if you notice, the very first one is a pre-job brief. Okay, that's the first one. Again, if we can identify as part of our pre-job planning, when we are in one of these situations that are error likely, we can plan for that. There's a bunch of other things there. I won't go through all of them. Number 12, certainly important. Stop if you're not sure. In the nuclear power industry, we have a rule that says you never proceed in the face of uncertainty. Okay. If you're not sure, what you do is you go to number 13. That's what's called a peer check, right? You get your coworker who's done this job before, right? And they've seen this and they understand the work and they have done it before. You get them involved, right? Or you just ask them simple questions, or your supervisor or an engineer or whoever it is you need. Get a peer out there to help you get through this work, do it safely, okay? I'll leave those there. Again, a lot of different things that we can employ in order to reduce the risk of human error. All of that is spelled out in Annex Q. Again, part of your pre-job planning, you can include your error precursors as part of that, and again, plan for those. In nuclear power plants, we certainly do. And if you looked at our website, we do have a pre-job brief card there, and part of it, our pre-job brief card, talks about the error precursors that we might be exposed to. And then on the back side of the page there, it gives you an example of all the different human performance tools that you can employ in order to reduce that risk of human error. All right, so again, ladies and gentlemen, have risk assessments and job briefs gone too far? Again, our feeling is no, they haven't. Again, if we looked at the nuclear industry, I think it gives us a pretty good indication or proof that the methods, again, required by NFPA 70E, right? Basically, we kind of made the case there that what we do in the nuclear power industry, if you follow NFPA 70E, you would be kind of doing the same thing that they do, can certainly reduce the risk of workers getting hurt. And so, again, how do we get our general industry to utilize these methods a little bit more effectively? And so, Jim, that would be the end of our presentation. Again, ladies and gentlemen, thank you very much for sitting through that. If you had any questions, we'd certainly be happy to answer those for you. If you had anything you'd like to ask us going forward, you can go to our website, or you can reach me at brian@70econsultants.com. Happy to help you with anything and everything revolving around electrical safety.
Thank you, Brian. That was excellent. It looks like we're close to being out of time. There is a comment on the question box that I found interesting, and I'm sure he's just put it there for informational purposes, but it's from Harold, who says that they use the QR codes on the arc flash labels to access all the documentation on the server for instructions for that specific piece of equipment, including lockout, tagout, and safety procedures. I thought that was a pretty clever way of disseminating the information.
Absolutely, yeah. Technology is a beautiful thing.
Well, thank you very much. Any questions that come up, we'll certainly forward them to you. And I appreciate you doing this presentation today.